Hi viewers, I am Agil, Assistant Professor, Postgraduate Department of Chemistry from E-Content Development Center, Majlis Arts and Science College, Promanur. In this section, I would like to discuss you with the long form of periodic table. So after completing this session, you will get a clear-cut idea about the long form of periodic table, and you will be able to relate the properties and the position of elements in the periodic table. So we can start the section with a very large question, that is how the modern periodic table is formed. So the answer is here. It is formed by the arrangement of elements according to modern periodic law. So next we have another question, what is modern periodic law? So modern periodic law says that the physical and chemical properties of elements are the periodic functions of their atomic number. That means in the long form of periodic table or in modern periodic table, the elements are arranged in the increasing order of their atomic number. So when we are arranging the elements in the increasing order of atomic number, we could see the properties are repeating after a regular interval of time, and it is termed as periodicity. So next we need to discuss the salient features of modern periodic table. So we could see this is the periodic table that what we are talking about. So in this periodic table, we know the elements are arranged in the increasing order of atomic number. We have already discussed that. And in this periodic table, you could see there is 7 horizontal rows, and that is called periods. And in periodic table, we have 18 vertical columns that are called groups. So simply we could say in the modern periodic table, we have 7 periods and 18 groups. So out of these 18 groups, the first group is known as alkali metals and the second group is known as alkaline earth metals. The group 3 to 12 are called transition elements, and group 18 is called noble gases. The elements of group 1 and 2 together with group number 13 to 80 are called representative elements. And in the periodic table, you could see 2 separate rows that represented at the below side, and the first row is called lanthanides. Actually, lanthanides is present in the 6th period after lanthanum, and the second row they are called actinides, and actually actinides are present in the 7th period after actinium. So now we can divide the modern periodic table into separate blocks. So the group number 1 and 2 constitute the S block. You could see that in the light blue color, and group 13 to 18 is constitute the P block. You could see that in green color, and group number 3 to 12 that constitute the D block, and you could see it's in the yellow color, and the inner transition element, that means the lanthanides and actinides, they constitute the F block. Now we need to discuss the periodicity in properties. In this, first of all, I could say the elements present in the same group that will having the same chemical behavior or same chemical properties. And in the periodic table, we could see a vertical relationship. Vertical relationship means if you are moving top to bottom or down in a group, we could see a regular gradation in their physical properties. Like that, also we have horizontal relationship in the periodic table, that is if you are moving left to right along a period, there also we can see a regular change in their physical properties. Next one is a very important diagonal relationship. So if you are taking an element in the second period, it will show resemblance in property with an element in the period number 3, which is placed diagonally right in position. So we can explain this with an example, lithium and magnesium. So lithium and magnesium showing diagonal relationship. So lithium it actually belongs to period number 2 and magnesium belongs to period number 3. And also magnesium is diagonally right in position with respect to lithium. And this kind of relationship is called the diagonal relationship. So apart from the example lithium and magnesium, we have other examples too. Beryllium and aluminum showing diagonal relationship, boron and silicon showing diagonal relationship, carbon and phosphorus showing diagonal relationship, and etc. We have a lot more examples. So next we need to discuss the merits of long form of periodic table. So we have discussed the salient features of periodic table. From that we can deduce the merits of long form of periodic table. So the first one, the elements are arranged on the basis of the fundamental property, namely atomic number. So we have already discussed that. Next one, elements of the same properties belongs to the same group. So this will help us to study the properties of elements. The transition elements, that is the elements that belongs to group number 3 to group number 30, and they will show the transition from highly electropositive metal which is present at the left side of the periodic table to highly electronegative non-metal which is present at the right side of the periodic table. So that's why they name transition elements. So one point that you need to remember at this time is, at the left side of the periodic table we have electropositive metals, and at the right side of the periodic table we have electronegative non-metals. Now the position of an element in the periodic table is closely related to its subshell electronic configuration. Here the period number of an element that will give the principal quantum number of the valence shell. That means if we know the period number of an element, we can predict the principal quantum number of the valence shell. And the elements in the same group has the same outer electronic configuration. So this is the reason for the elements in the same group that having the same properties. And the table may divide it into different blocks. We have already seen that S, P, D and F block, and this division is based on the subshell in which the last electron is filled. For example, if the last electron is filled in the F subshell for an element, that element will belongs to S block, and if the last electron is filled in the D subshell, that element will belongs to the D block. For example, we know lithium. In the case of lithium, the last electron is filled in the S subshell, so that lithium belongs to S block. In the case of carbon, the last electron is filled in the P subshell, and carbon belongs to the P block, like that. And the table that's showing the horizontal, vertical and diagonal relationship. Periodic table having lots of merits. With that merit, it also having demerits. First one, anomalous position of hydrogen. So when we are observing the periodic table, we could see that hydrogen belongs to group number 1. When we are closely observing the hydrogen, we could see a little gap between the hydrogen and the rest of elements in the group 1. This is because by considering the electronic configuration of hydrogen, hydrogen should be with the group number 1, but hydrogen show resemblance in properties with the group number 70. So there is a little bit confusion about the position of hydrogen in the modern periodic table. And the second demerit is position of helium. So in the periodic table, the helium is placed in group number 18. So here, by considering the electronic configuration of helium, helium should be with the group number 2, because the helium having the outer electronic configuration NS2, so it should be with the group number 2. But helium show resemblance in properties with the group number 18. So that's why we place in the helium with the group number 18. So this is the demerit of the long form of periodic table. The next one is the position of lanthanides and actinides. We have discussed that lanthanides that actually belongs to period number 6 and actinide belongs to period number 7. Even though we have represented the lanthanide and actinide at the below side of the periodic table, it's not with the period number 6 and no period number 7. So this is the third demerit of long form of periodic table. So the next one is the electronic configuration of some elements like chromium and copper. They are disagreeing with their position. So these four are the demerits of long form of periodic table. Now let me conclude. In this section, we have discussed about the long form of periodic table. We have discussed how the periodic table is formed, and we have seen the salient features of periodic table. We have discussed or we have deduced the merits of periodic table, and also we have discussed the demerits of periodic table. I hope everything is clear to you. You study well, learn well. Thank you.